extending the network with switches, the Witty way. We've learned that networks were originally extended with hubs, but they didn't help with issues commonly related to bandwidth utilization, processing, and collisions. This is due to how hubs operate. Signals come in one port and the hub sends them out every other port. This happens for every signal. It's essentially a repeater. These negative issues resulted in the creation of the switch. Think about it like the switchboard operators back in the day. When a person in one home wanted to make a phone call to another, a switchboard operator would connect the phones, one line at a time. They were able to accomplish this through what is known as a switchboard. Here is my switchboard. Each of the devices is connected to one of the ports on the switch. Host A generates a frame for host B and sends it to the switch. The switch analyzes the frame and sees that it's coming from a host with a MAC of AAAA and is destined for a host with a MAC of BBBB. Here's where the magic of the switch occurs. The switch heard of a frame on port gig 00 from host A, so it will annotate that in its MAC address table, which is its source of truth for where a device is located out of all of its ports. The switch uses the source of incoming frames to fill its MAC table. This is why a switch is considered intelligent versus a hub. It has a way to make decisions. The switch checks its MAC table for the location of the device with the MAC BBBB. But as you can see, it doesn't yet have an entry for that destination. For this reason, the frame it is processing is known as an unknown unicast frame. That is because the switch has not yet learned where that MAC address is located. The switch decides to flood the frame. This means that it sends it out all the ports except the one that it was received on. The hope is that the destination device will receive the frame and respond, allowing the switch to process its frame and annotate its location. Like a logical switchboard operator, the switch begins to quickly make connections between the source port and the destination ports. It ensures every connection gets a copy of the unknown unicast frame. This is flooding. Host B is ready to reply to host A and generates a frame. It sends it to the switch. This is the switch's first time hearing from host B. It processes the frame and annotates the location of host B in its MAC table. The frame is destined to host A, which the switch has an entry for. So the switch makes one single connection from the port of host B to the port of host A, and it sends the frame across. The other two ports are filtered because the frame is not destined for them. With the switch now aware of the location of both host A and host B, all communication is sent directly between the two. This eliminates unnecessary frames on the link, which would eat up bandwidth, and it eliminates host C and host D from having to process frames that are not destined to them. Lastly, each connection is its own one-way travel lane, eliminating collisions. As you can see, switches not only extend the network, they improve performance. It's now time to try this out in our lab. If you haven't already, download the available Packet Tracer lab from my website, wittynetworks.net. The initial lab network is extended with the hub. We want to improve our network, so we must first replace it with the switch and reconnect the devices. Next, we will take a look at the switch's MAC table with the Show MAC Address Table command. As you can see, the MAC table is empty, as is to be expected. Let's turn on simulation mode so we can see the frames as they move throughout our network. Log into host A and initiate a ping towards host C at IP 10.1.1.4. In the simulation window, hit the Next tab until the frame has reached the switch. We will now look at the switch's MAC table again. You will see that it now has a MAC address associated with a port. We'll log back into host A to see its MAC address and verify that that is the one that the switch is aware of. Issue the ipconfig/all command, and you'll see that the MAC addresses are a match. Return to the simulation window and hit the Next button again. As you can see, the frame is sent to host B and host C. Although this is like a hub, remember that the switch has to do this because it is unaware of where host C is located, so it must flood the frame out of all ports except the one it arrived on. Hit the next button in the simulation window once more. The frame from host C should get to the switch and stop. Take a look at the MAC table. There is a second MAC, and if we are correct, it should be the MAC of host C. Verify that. We continue through the simulation, and as you see, all communication is directly between host A and host C, as we saw previously. You have now been able to see how a switch is not only able to extend the network, but improve performance by using its main task of forwarding, flooding, and filtering of frames.